The Artemis program, led by NASA and supported by international and private partners, is the United States' ambitious return to the moon after more than half a century. While the Apollo missions of the 1960s and 70s were about proving technological superiority during the Cold War, Artemis is different. It's about building a sustainable presence on the moon. The goal isn't just to plant a flag and come home, it's to establish an enduring lunar infrastructure that will serve as a stepping stone for future exploration, especially missions to Mars. One of the most significant ways Artemis will reshape lunar exploration is through its focus on the lunar South Pole. Unlike the Apollo landing sites, which were in equatorial regions, the South Pole has areas of permanent shadow inside deep craters. These craters may contain vast deposits of frozen water, an invaluable resource for astronauts. Water can be purified for drinking, split into oxygen for breathing, and converted into hydrogen fuel for rockets. This shift in landing location marks a fundamental change in strategy. The moon will be explored not just as a place of scientific interest but as a resource-rich outpost. The technology behind Artemis is also groundbreaking. The Space Launch System, SLS, is the most powerful rocket NASA has ever built, designed to carry astronauts and heavy cargo directly to the moon. Alongside it, the Orion spacecraft is equipped with advanced life support systems, improved radiation shielding, and more room than the cramped Apollo capsules. These upgrades will allow astronauts to spend more time on the moon's surface and venture farther from their landers, greatly expanding the scope of exploration. Artemis will also benefit from unprecedented international collaboration. The Artemis Accords, signed by over 24 nations, set guidelines for responsible space exploration, resource sharing, and avoiding territorial disputes. Partner agencies like the European Space Agency, ESA, the Canadian Space Agency, CSA, and the Japan Aerospace Exploration Agency, JAXA, are contributing key technologies, such as robotic arms, habitat modules, and lunar rovers. This global approach could turn the moon into a truly international scientific hub. Another major innovation is the Gateway, a small space station that will orbit the moon. The Gateway will act as a staging point for lunar landings, enabling missions to use smaller, more efficient landers instead of carrying everything from Earth. It will also serve as a research platform, communications hub, and even a test bed for technologies needed for deep space travel. By building this permanent infrastructure, Artemis will make lunar exploration more routine and less dependent on single massive missions. Artemis is also paving the way for a new era of public-private partnership in space. Companies like SpaceX, Blue Origin, and Dynetics are developing lunar landers under NASA contracts. This diversification of suppliers is expected to reduce costs, increase innovation, and allow more frequent missions. Private industry will likely play a huge role in developing mining equipment, habitats, and transportation systems that could eventually make the moon a place where not just astronauts but also scientists, engineers, and even tourists can live and work. The missions are designed with inclusivity in mind. Artemis aims to land the first woman and the first person of color on the moon, reflecting a broader commitment to diversity in space exploration. This symbolic milestone goes beyond representation. It's a recognition that humanity's future in space must involve talent from all backgrounds. By inspiring more young people globally, Artemis could create a broader, more diverse generation of scientists and explorers. From a scientific perspective, Artemis offers enormous potential. The moon is like a time capsule for the early solar system, as its surface preserves geological features billions of years old. By studying rocks and soil from unexplored regions, scientists hope to learn more about how the Earth and Moon formed, the history of asteroid impacts, and even whether life's building blocks could have originated in such environments. The South Pole's ice could also reveal clues about the history of water in the solar system. Importantly, Artemis is not just about exploration for exploration's sake. It's about proving the technologies we'll need for interplanetary travel. Long-duration lunar missions will test systems for habitat construction, radiation protection, in-situ resource utilization, and autonomous operations. These lessons will be critical when humans eventually make the leap to Mars, where resupply from Earth will be impossible, and survival will depend on self-sufficiency. In the long term, Artemis could redefine humanity's relationship with space. If the program succeeds, we might see a permanent, thriving lunar presence by the 2030s, with mining operations, research bases, and perhaps even manufacturing facilities taking advantage of the moon's unique environment. The moon could become a launch point for missions deeper into the solar system, reducing the cost and complexity of reaching Mars, asteroids, and beyond. Artemis isn't just a mission, it's a blueprint for turning the moon into humanity's first true home beyond Earth.